Hey guys, what's going on? I had a little glitch there, but I think I'm back here. Blue guy, blue path, 23 miles. Green path, we just said it was 17. That's right where we left off. All right, so let's see here. I got blue trip of 23 miles. I got green trip of 17 miles. That means if we go on the shorter trip, it's shorter by 6 miles. All right, looking pretty good. Slide down to the next one. Circles. When's the last time you had a circle in front of you? Back in geometry, you should have done a lot of work with circles, but one thing we here talk about is the equation of a circle. So circles have an equation that revolve around their center point, that's h comma k, and also their radius, which we always like to call r. Equation for a circle, knowing what its center point is x minus h being squared, y minus k being squared, equals to the radius squared. So if we got a center right there, hopefully without a doubt, we can say that our center point is at -1, +2. Now, of course, that should be pretty clear for you there. But now think about the radius, right? The radius is going to be the distance from the center to the arc. So if I call that the radius, from -1 to +5 is 6 units. So in our problem, we got an h value equal to -1. We got a k value equal to 2. We got an r value equal to 6. X minus -1 becomes x plus 1. Y minus k becomes y minus 2. And then the radius has to be squared there. So radius is 6. 6 squared is 36. Let's see what's matching up there. X plus 1 squared, y minus 2 squared equals 36. Best answer for that one, letter D. All right. So again, additional math concepts, hopefully really sparking some good mathematical thoughts there in your brain. All right, check out number 9 here. And of course, 27. As always at this point, just hit that pause button and try to work those two out and come on back and I'll walk you through the problem. If we know that angle Q is 140, first of all, look at that right there, right? There's your straight line idea. If I know that Q is 140, then without really having to think too much, I should be able to say that P is 40, right? That's our straight line game there, guys. That's your supplementary angle concept. So hopefully if we say our P plus our Q's got to be equal to 180, and our Q value has been given to us as 140, then we all hopefully know what do you have to add to 140 to get that 180, right? That P value has got to be 40 degrees. So I'm going to start with that thought, right? Right away, I know building my angle connection here, this guy is 140, that guy there is 40. Now in vertical angles, which are right here, those guys are equal to each other. So if angle P is 40, then inside the triangle that we have, that's also got to be 40. And if we look at this triangle right here, it's a nice right triangle. Blow it up a little bit. We got 40 there. Angle with 90, that makes that triangle complete. Again, all three angles of the triangle have to add up to be 180. So we'd be, all right, well, we got 90. We got 40. What's got to go there, right? Whatever angle's got to go there has to make equal to 180. So you got 130, so that's got to be 50. right, so now that angle is 50. So right now we got P coming across at 40 degrees. If you notice, we have to find out what R minus P is. So we're looking for R. Well, again, we're back on that straight line game here. Here's that straight line, right? If that interior angle there is 50, then that means right there's got to be 130. 50 plus the 130 got to make 180. Question is to find R minus P. R is 130, P is 40, 130 minus 40 is 90. Answer C. Question 27. Right triangle, even more important, isosceles right triangle. So if you remember our rule about isosceles right triangle, this guy here, by definition, is going to be 45, 45, 90. Put those little slash marks in there. That means that those guys are equal to each other. So that's 7 root 2, and that's another 7 root 2. So the question is, what is the value of H equal to? If you memorize 45, 45, 90, pretty straightforward. If you forgot, then it's going to be 7 root 2 being squared plus 7 root 2 being squared is equal to H squared. So if I take 7 square roots of 2 and I square that quantity, that's going to be 98. So that's 98, that's 98, and that's equal to H squared. 98 plus 98 is equal to 196. 196 is equal to H squared. Solve for H, you take the square root of both sides. Square root of 196 should give me 14. That would be the direct Pythagorean theorem route. If you measured a 45, 45, 90, and remember the connection between the side lengths, there's also a nice thing that you should know about 45, 45, 90s. I kind of put it out here for people that remember that. And make it a little better. This is a formula that's out there. We say the values of the legs are both equal to x, and the hypotenuse is x root 2. So the other way to be thinking about it, if we knew this was 7 root 2, we could take the 7 root 2 and multiply it by root 2. And that also will get you there if you memorized 45, 45, 90. 14 for sure. Good connections, advanced math topics, really in the spectrum here of algebra, tied into some of your geometrical concepts, right? All right, some more geometrical concepts here for you. And hit that pause button and try these next two. All right, question 34 wants you to make these triangles congruent by using angle side angle. So if we think about what's going on here, angle A is congruent to angle D. So there's A, and there's D. They're equal to each other. AB is congruent to DD. So those are together. So right now, we got the angle and the side. We need another angle. Well, hopefully, without a doubt, it would be, I got to go E kind of B. If E and B are congruent, we would now have completed the angle side angle theorem. Question 36. Very good question here. Of course, they'll tell you this on SAT. These guys are not drawn to scale. What is the area in square units of the triangle that is not similar to the others? All right. As you're looking at those numbers, what do you start to see? And I go to this guy right here, 10, 24, 26. All those numbers are divisible by 2, right? So that would be a 5, 12, 13. Check out this one. These guys are all divisible by 3. That would be another 5, 12, 13. Over here in this problem, these guys are all divisible by 4. That's another 5, 12, 13. So these 3 here are all similar. So that means we got to work with this triangle, right? That triangle must not be similar. If I bring that triangle down there, so we got 32 here, we got 24 there, we got 40 there. What's your greatest common factor, right? That would be a 6. 6 goes in there 3 times 8. I'm sorry, whoops, 8, my fault. 8. 8 goes in there 3 times. 8 goes in there 4 times. 8 goes in there 5 times. That would be a 3, 4, 5. And of course, that's not similar to the 5, 12, 13s. So this is the triangle that is not similar. Find the area of the triangle that's not similar. Okay, area is equal to 1/2 base times height. In this problem, we like to say the base is 24 and the height is 32. Area of that triangle is going to be 1/2 the base value, again, 24, height value, 32. What is the area of the non-similar triangle? Pull out your calculator on that one. Of course, you guys all know 1/2 is 0.5 times the 24 times the 32. 384. Answer got to be D there. Again, hit the pause button. Additional topic here, talking about I. If you've never seen I before, they do give you a little hint. I is equal to the square root of -1. Also, if you have a calculator, there is a button on your calculator that has I in it. Again, hit the pause button, come on back and check out what your answer is and see if it matches up with mine. This problem is the distributive property, right? So if we say we got 4i and we got to multiply it by 5 minus 7i, first things first would be if we multiply the 4i times the 5, that gives you a 20i. Oh, there's 2 questions that have 20i in them. We take the 4i and we multiply it by the -7, that makes -28i squared. So we do say that I is equal to the square root of -1, and I squared is -1. So if I squared is equal to -1, we could use that right here. So we got 20i minus 28 times -1. So we got 20i plus 28. Again, if you want to put in the proper form there, number first, 28, I part second, 28 plus 20i. Looks like it's right there in letter D. I'll make that a little bit neater for you on your side of the screen. But answer should be D there. Positive 28, positive 20i. Again, you just got to use your distributive property to get that done. All right, so here's another one. Another one that involves working with I. Which of the following shows the product of these two together written in proper A plus BI form? And if you've worked with I before, you already know. If you haven't, then you need to kind of hopefully pay close attention here. So what do we know about the square root of -9? Well, that's really 3i, right? And I just break this down for you if you've never seen it before. It's a square root of 9 times the square root of negative 1. Square root of 9 is 3. Square root of negative 1 is I. So first thing is that becomes 2 plus 3i. Next part, what do you think about the square root of negative 4? Square root of negative 4 is square root of 4 times square root of negative 1. Square root of 4 is 2. Square root of negative 1 is I. So now that's going to become negative 1 plus 2i. So what has to happen in this problem is you have the FOIL. Classic FOIL problem. 2 times negative 1 is negative 2. 2 times 2i is 4i. 3i times negative 1 is negative 3i. 3i times 2i is 6i squared. Combine your like terms, but remember, guys, here's the key. I squared is equal to negative 1. So that's negative 2 plus, those guys are like terms. 4i minus 3i is just 1i or I. 6i squared, that's 6 times negative 1. Remember, I squared equals negative 1. So now that becomes negative 2 plus I minus 6. Final answer, negative 2 minus 6 is negative 8, excuse me. Negative 8 plus I. Answer there, gonna be A. Got a nice chunk of problems there that really deal with some additional topics in math that you maybe have never seen before, haven't been exposed to, but at least trying to touch our bases here and get all of our concepts that you'll see on SAT. A few more to go, guys. Another complex number problem. Right? Again, complex numbers come in the form of a plus bi. We like to say that we know that the square root of negative 1 is equal to I, and we also know that I squared is equal to negative 1. Kind of using that note. All right. Absolute value of a complex number is square root of a squared plus b squared. And we're looking at an a of 15 and a b of 8. Checking on out here, guys. A's right there, B's right there. So what they want you to find is they want you to find the square root of a squared plus b squared. Okay, well, the value of A is 15. The value of B is 8. Prosperity's sake, accuracy's sake, do it on your calculator. Take the square root of 15 squared and add that to 8 squared. Poof, answer is 17. Now, you guys know you're going to have that free response part, right? So I always say take your number, move it over as far as you can to the right. 1, 7, right? So you bubble in the 1 and you bubble in the 7. Free response portion. Number 12. Now, depending on where you've been and where you came from, and of course what you had last year again in geometry, you should have covered some SOHCAHTOA stuff. Never heard of SOHCAHTOA? You probably could Google it real quick. It's just a nice little rhyme that ties in the trigonometric functions. So the question is, which of the following is true? All right, so we got an angle of 67.4. You guys all know across from the right angle is what we call the hypotenuse. Over here would be your side opposite, and over here would be your side adjacent. Now, if we look at the measurements that have been given to us, I call that the CA function. The cosine function in mathematics is equal to the adjacent side divided by the hypotenuse. Okay, so our adjacent side is 5 and our hypotenuse is 13. We could say that the cosine of the angle that was given to us of 67.4 degrees is supposed to equal to adjacent, which is 5, divided by hypotenuse, which is 13. And once again, you should have done some SOHCAHTOA or some right triangle trig back in geometry. If you've never seen right triangle trig, if you never heard of SOHCAHTOA, obviously that's something that you could probably guess that on the test, skip the problem, come back to at the end, and then hopefully what we just did at least gives you a little bit of insight about SOHCAHTOA. All right, 2 last problems here for our additional math concepts. Another connection about spatial relationships with trigonometry. I like to kind of go to number 5, first of all. Again, we like to call this right triangle trig. I was going to draw a triangle there, but if I tell you that an angle measurement has a tangent value of 7/24, first thing I would do is I draw a right triangle. I call an angle X, and again, I invoke my SOHCAHTOA. Tangent function is always going to tie in the opposite side divided by the adjacent side. So of course, over here would be opposite, here would be hypotenuse, and then down over here would be adjacent. So if we have tangent has been given to us as 7/24, then that means opposite has got to be 7 and adjacent has got to be 24. 7 here, 24 there. What's the sine value? The sine value is what we call SOH. Sine of that angle X is going to be opposite over hypotenuse. So we don't know what the hypotenuse is in number 5. Again, Pythagoras theorem will lead us there, right? A squared plus B squared equals to C squared. My A value is 24. My B value is 7. We got to find C squared. 24 squared plus 7 squared is going to be a pretty big number, 625. If C squared is 625, you solve for the value of C by taking the square root of it, so that's 25. My hypotenuse, I just found that to be 25. So I now have 3 measurements of the side lengths of a triangle, and I'm asked to find the sine value there. Again, sine of an angle measurement from a right triangle is going to be opposite. And here's X. There's my opposite over my hypotenuse. 7/25. So we'd be 7/25. Classic bubble in the 7, bubble in the division sign, bubble in the 2, bubble in the 5. All right, and then finally, this last question here, number 11. Again, this is that beyond topic, guys. This is pretty in depth. If you never seen this stuff before, you haven't been exposed to it. It's just a standardized test question that is trying to reach to, advanced math here. So what we should know about angle measurements and where they lie in the coordinate plane goes back to, of course, what we like to talk about is the circle. The cosine of which of the following angles is not equal to the cosine of the other 3. So if we plot these angles here, first of all, where's -120, right? -120 would be back in this direction, probably right about there. -60 would be right about there. +120 would get us right there. And then, of course, 240 degrees would also get us right over here. All right, so if we look at the angle measurements and we think about their cosine value, big thing about this problem is cosine is going to be the same value with the same value as far as being positive or negative when you look at your quadrants 1, 2, 3, and 4. Right? Both of these values here have the same cosine value being negative. This guy would not work. Negative 60 degrees is not going to give you the same value as the other three. And again, we like to say this one not equal to the other three is negative 60. You could also do this on your calculator. Again, just for a quick idea, if you take your mode button and you slide down and you put it in degrees, and you try these numbers on your calculator. What's the cosine of negative 120? What is the cosine of negative 60? What is the cosine of 120? What is the cosine of 240? You notice 3 of them are all negative 1/2. And the one that's not negative 1/2 is positive 1/2, which is coming from the cosine of negative 60 degrees. That's the one that doesn't work. All right, that was a full hour of power over here on my side of the camera. I hope that you guys all do well on your SAT exam on Tuesday. If you do have any last minute questions or concerns, feel free to zap me an email and I'll get right back to you. But I think we've done our due diligence here. We've taken you through 5 weeks of material, got some good notes on our Google Classroom, and hopefully you've been exposed to the major topics that you're going to see on your SAT exam. So thanks for all your hard work. I hope you got something out of our time together. And of course, it's been a pleasure working with you guys. My goal is that you are going to score well in the math portion of the SAT. And hopefully from some of the exposure of the questions that we worked on together, that's going to be something that comes to fruition, right? That's going to be something you feel comfortable with